тіло ми положим за нашу свободу і покажем, що ми браття козацького роду. Душу і тіло ми положим за нашу свободу і покажем, що ми браття козацького роду.
And also the minute of silence will be now. Thank you so much. And now we will have introduction word from Grigory Mozelevich, General Director of the Science Development Directorate of the Ministry of Education and Science of Ukraine. Thank you, Grigory, that you are with us today.
Dear colleagues, dear partners, thank you for the floor. Maybe I say in Ukrainian, maybe in English. Now I waiting from Словакія. Давайте українською, мабуть. Я повертаюся зараз зі Словаччини разом з урядовою конференцією. Ми мали урядові зустрічі з нашими партнерами, з нашими сусідами, в тому числі і з питань освіти і науки, так само, як і з безпекових питань, таке інше. І маємо, думаю, що ви бачили з засобів масової інформації новину, яка трошки турбувала наше суспільство щодо підтримки Словаччиною руху України до Європейського Союзу і у оновленого уряду, і оновленого керівництва цієї європейської країни. Так само, як і Словаччина готова нас підтримувати в тих рамках державної політики, які зараз здійснює Міністерство освіти і науки України, реалізуючи відповідний стратегічний план МОН до 2027 року. Тож, це, я вважаю, добра новина, і добре, що чергові партнери готові нам допомагати, незважаючи на оновлення керівництва цієї країни. А вже повертаючись до вашого заходу, хотів би побажати вам цікавих доповідей, цікавих питань, цікавих обговорень. Зрозуміло, що аерокосмічна галузь для України і аерокосмічні дослідження є актуальними вже, мабуть, 60-70 років як мінімум, можливо, навіть більше. Я так само, як і Анастасія, родом з серця космічної галузі з міста Дніпра. І я так розумію, що і багато наших земляків сьогодні будуть мати доповіді. Впевнений, що ті підприємства наукові, які не тільки на Дніпропетровщині знаходяться, і в інших містах України, мають відповідні наукові результати і надбання, які зараз ми можемо використати для захисту нашої країни, зможемо ці надбання використати і в майбутньому. Тож, бажаю вам, щоб цей захід дав вам натхнення до нових наукових результатів і звершень. Дякую за увагу і до наступних зустрічей.
So much, Grigory. I will tell like in 2 words because we have today our foreign colleagues here. So Grigory wish us very nice event with interesting reports, and he told that this aviation and rockets space industry is very important for Ukraine for the last 60, 70 years, and that he is now returning from Slovakia, and that this country supports Ukrainian integration to European Union, and also all activity of the Ministry of Education and Science of Ukraine according to this process. And also, Grigory highlighted that rocket space industry and these achievements in this sphere is very important for our future of Ukraine. So he wish all of us good luck. Thank you. And now let me give the word for introductory word for our Olesya Vasyuk, Head of Young Scientists Council at the Ministry of Education and Science of Ukraine. Please.
Thank you. Hi, ladies and gentlemen, esteemed colleagues and fellow scientists. It's my profound pleasure to welcome you all to this roundtable discussion on the achievements of the young scientists in space and aviation, hosted by the Young Scientists Council at the Ministry of Education and Science of Ukraine. Today's event promises to be a fascinating exploration of the groundbreaking contributions that young scientists have made to the fields of space and aviation. In recent years, the pace of innovation and discovery in these sectors has been nothing short of astonishing. The work being done by the coming generation of scientists and researchers is not only pushing the boundaries of what is possible, but also laying the groundwork for future explorations that will propel humanity even further. The primary aim of today's gathering is twofold. First, we will showcase the remarkable scientific achievements of young Ukrainian scientists. Their work, often on the cutting edge of technology and research, has contributed significantly to our understanding and capabilities in both space and aviation. From advancements in aerospace engineering to innovative satellite technologies, their contributions are shaping the future of how we interact with the cosmos and our aerial environments. And second, we seek to foster and discuss the prospects for international collaboration. In an era where global cooperation is more important than ever, it is crucial that we come together to share knowledge, resources, and visions. The partnership format here can help accelerate progress in these vital fields, driving forward mutual benefits and shared success. This event is being streamed online, accessible to all through our Facebook page, not our Facebook and YouTube channel too, allowing for broader participation and intersection from interested individuals around the world. We encourage you to engage, ask questions, and contribute to the discussion as your input is invaluable. We are particularly proud that this platform not only highlights scientific achievements, but also promotes dialogue among young scientists from Ukraine and their international peers. Such interactions are essential for fostering a collaborative scientific community that thrives on shared knowledge and collective efforts. Thank you for joining us today. Whatever you are, a scientist, maybe student or future student, or simply an enthusiast of space and aviation, your presence is appreciated and your participation is crucial. Let us look forward to an event filled with insightful presentations, stimulating discussion, and promising opportunities for future collaboration. Let the session begin, and may our discussions be as expansive and enlightening as the universe we aspire to explore. Come.
Thank you so much.
Yeah.
Thank you so much for some warm words. So we will start, and today is our fourth event. So for years we make such events like roundtables and some discussions. And today we have our event with foreign participants. So firstly, we have it in English. And our first participant, also, I remind you that now we will have presentation. After that, we will have discussion session. So please be in your limit of time. So our first participant is Alexander Lyubimov, National Aerospace University, Kharkiv Aviation Institute. Please, Alexander, floor is yours.
Thank you very much. I'm starting up. So first of all, I'm really thankful to open the practical side of this event. And I want to congratulate everyone with the Ukrainian Day of Aerospace Industry. So we all deserve it. So let's talk today about a little practical, but also interesting topic about how to build the CubeSat industry in Ukraine to be commercially available for all of us. So to be able to onboard you to what is the concept of CubeSats, I would want to demonstrate some slides with some graphics about what it is. So the CubeSat idea was started in 1996 in California, where a few scientists gathered together and kind of decided, okay, how to industrialize space in a cheap and affordable manner. And they came to the idea that they can make satellites that are as small as a Rubik cube, and they can be built on, if we are talking about 1U size, 10 by 10 by 10 centimeters bricks, that could be stacked up to 24 pieces next to each other, and then you can erect it to the low Earth orbit, meaning here we are talking about 400 kilometers range. That was the idea how all this started. So what they wanted to address with this concept is to make space affordable, so it's easy to erect something there, use it for technology demonstration, for scientific research, educational projects, and the commercial purpose. And here on the right side, you can see the very first Ukrainian CubeSat that was pushed by National Technical University of Sikorsky, KPI, back in 2000 something. So it's 1U CubeSat that was really starting the Ukrainian CubeSat industry. So what is there for today? Well, first of all, you can see on the screen that except of the low Earth orbit, that was the initial target for the CubeSats, CubeSats have been pushed also to the Moon orbit and to the Mars orbit. And you can see that there are actually few satellites out there that are now carrying the scientific payloads. And also on the right side, you can see the second Ukrainian CubeSat that was pushed again by Kyiv Polytechnic University there, and it's still operating. One of the interesting concepts of the CubeSats is that actually they are not creating excessive space garbage, because the low Earth orbit is a decay orbit. So actually, whatever you push to the orbit will be accidentally going back to the to the atmosphere of the Earth and then burn. So actually, it doesn't remain there with a lot of garbage that we know is out there today. So why CubeSat industry is important for Ukrainian space? Well, first of all, so far we have been trying to erect three satellites there. Two successful, one failed, so it's very small amount. If you look into the industry overall, we have more than 2,700 satellites that are pushed to the space by all other nations, and we are definitely behind. I think the majority of the Ukrainian CubeSats that were pushed, not many, but still, they were 80% based on the commercial equipment that is generated by other countries. So it's not our domestic development. And the only available, basically, CDHM, meaning the central computing platform that is designed by Pirdenne and Hartron, that's all fine, but it's not available for the industry, and it's also has not been used for the so-called flight heritage. So that's really a problem for us. And you can see also on the map here, this is the distribution of how many satellites, CubeSat satellites, were pushed to the orbit by different countries. And you can see Ukraine here having only three satellites. So even a small and non-industrial countries like Armenia have one satellite out there. So we have to really pick up, we have to carry on and move on. So how I started the idea, I'm defending my PhD thesis in Kharkiv Aviation Institute, and the project that is at HAI is called HAI-DIMSAT. You know, HAI has been erecting the first ever satellite to the orbit, so and that's why HAI decided to kind of, you know, push for the first CubeSat as well. And you know, now we're behind. We cannot be first among the universities because apparently Kyiv National University has been pushing 2 satellites out there. But there is a challenge, there is a task for HAI to be able to pick up this race. So why do we want to make our own computation platform? Well, first of all, the idea, the concept of this commercial computation platform is to make it available. So it's out-of-box approach. So you can take it and you can put your payload on top of it, and then you can just go and decide or solve your basically scientific or commercial mission. Secondly, we want to actually use modern NASA software framework as a part of the product. So we don't want some homemade software here and there. So people are fighting with having it stable and having it actually reused. So we want to piggyback on the NASA, open source NASA frameworks. So we want to, as I mentioned, we want people to concentrate on their missions rather than system programming or integration. And we want to have a product to be completely out of dual use or export control components. So we can actually have something that can be just as easy as import of the mobile phone. And then apparently we want to give back to the Ukrainian space industry, so we can have we can be back on track with actually being a space country again. So that these are some of the top level targets. Okay, so what I have created as my work is a platform called Falco, and Falco is a very small predator bird in Ukraine called Boroviter, that you can see on the right side here on the screen, catching some mice and stuff. And that's why we really want to move this, you know, this computation. This is only one part of the CubeSat. You can see here on the right side that it contains different parts, but the central computing unit that is called CDHM, that's what me and my scientific team has developed. How far did we go so far? Well, we are at technology readiness level 5, if you know the NASA framework of technology readiness, meaning that we have components that are ready to be integrated to the entire CubeSat. And we are working mainly with integration of actually 2 frameworks of NASA, the modern one called F prime, and a little bit more flight mature called CFS, Core Flight System. That's where we at with the project. Here you can see the example of the hardware that was created and now also qualified the basic testing like electromagnetic compatibility, sorry, and some humidity, temperature, vibration tests. Why we also want to push that platform forward, because we believe that it can be used as a dual use platform. It can be used for modern UAVs, unmanned, aero products, and this is where we actually already tested migration to ArduPilot platform. So actually, the platform we have supports ArduPilot, and it can make missions and tasks related to the UAVs, and also it can be used even more for unmanned robotic platforms that are used everywhere today, and that's one of the extra motivation to actually perform this project. So if you look into the roadmap of the existing CubeSat computation platform program, then basically in 2022 I joined the HAI team with the idea. So we're working on different concepts. We are talking about actually what we want to construct. Proof of concept we have finished in 2023. That's where we constructed samples and started hardware and software verification, integration and stuff. This year, we are finishing actually integration with other platforms and porting the software and finalizing compliance testing. And 2025, we are planning to actually integrate the first payload and get it erected together with NanoRacks as part of the Ukrainian space program. So what I want to say as the final word of my presentation is that we want to co-develop and explore science and space together. We don't want everyone to be boxed and developing their own solutions. We want to make an impact. We want to be, together with the rest of academia and industry here. So we want to utilize modern European approach, co-creation and technological growth. And we want to get back to the low Earth orbit with our product. So we want to be back to the space race. We want to be back to the space cooperation with other countries and nations. Thank you very much. That's the end of my presentation. I will be happy to connect with you in the science networks, but also on LinkedIn. So you're welcome to follow me, and actually I'm open for any cooperation related to the space industries. Thank you.
Thank you so much. You can write your contacts in chat that everyone will see. Dear colleagues, I remind you about our time limit. Please be on time. And our next speaker will be Timo Mustonen from Finland, Sustainable Space Economy. Please, Timo, floor is yours.
Thank you. It's a great privilege to be joining your event today. And if there are any ways, if I can open the doors to the Europe or US or anywhere, I'm delighted to do it. I hope that you can see my screen now. Okay. So I'm the founder of Sustainable Space Economy, and I already introduced myself. I'm very active on LinkedIn, so if you are not already connected with me, please send your connection request. I don't want to have you as a number in my network, but I want to see you as my friend on LinkedIn. I will be talking today about scaling sustainability in the space economy on Earth and in space. What it means in practice that I want to cover downstream and upstream parts, not only the space part. We all know that space is very much unknown at the moment. People don't know about the opportunities which we have there, how work in space can support our lives on Earth. There's also a study made by Viasat last year. They even interviewed 20,000 people in 11 countries. And the end result was that it was a real wake-up call for the industry to educate people on all that space is delivering to their everyday lives. Even 97% of all respondents see that space is a threat. They were thinking about space junk and climate change as the main concerns. So there's a real reason to educate people around the world how space can be utilized in a sustainable way to improve quality of life on Earth. Sustainable Development Goals from United Nations, I believe that you are familiar with those. It's a major opportunity for the space industry. It's about business potential. It's a 12 trillion USD business opportunity. I hope that different organizations and companies are willing to show thought leadership an expert on sustainability. There's a funding available. The level of sustainable funding grows drastically at the moment. Then there's a commercial part that when companies have customers and suppliers, they will start asking what you are doing with sustainability. Recruiting, based on the studies, 80% of the millennials want to have sustainability focus in their companies and organizations where they work. And this is not going to go away. If I think about my 19 and 15 years old daughters, they talk about sustainability almost every day, and it's already in their DNA. Sustainable development goals add also long-term value. It will be helping to design a business plan, how to manage the change. And sustainability and sustainable development goals are not fading away. It's a fundamental shift, and it's all our responsibility to be more accountable and responsible to meet the global challenges. Then a few words about sustainable space economy itself. The vision which we have is how to improve quality of life on Earth, and equally to all of us, not only for the rich countries, for example, and how to utilize space in a sustainable way, for example, avoiding hazard chemicals or space debris. And then the third dimension is that there are very many young people who are not decision makers, but we are. So we are supposed to make wise decisions on their behalf. Sustainable Space Economy wants to show leadership as a global, non-political, independent, and execution-focused social enterprise. So finally, we don't want to see only people talking and talking, but we want to increase awareness of the people about the space and opportunities there, and then focus on execution, because that's really what matters. As I told you earlier, Sustainable Space Economy is a social enterprise. So it has two angles. It has non-profit and for-profit part. First one is that we show thought leadership, increase awareness and collaboration between different organizations and people and the companies. We have several tools how we do it. And one reason for joining today is that I want to increase the network, I want to partner, and see the people who share the same values in their heart with me. The money part, how we are, because we are forced also to make some revenue to cover our expenses, is that when companies and organizations are saying that, hey, we understand the value of sustainability and we want to do something, then together with the partners, Sustainable Space Economy is helping them to validate their business models, pivot those, and execute towards Sustainable Space Economy holistically on Earth and in space. So the owners of Sustainable Space Economy don't want to be a billionaires, but we want to cover our own expenses and make sure that the future generations will have better planet after us. I wish that you are excited to join this most impactful global initiative platform, bringing sustainable value to space economy on Earth and in space. Please visit our website and subscribe to our newsletter, and then become a change maker on our global community. And I'm really talking about community. I want that we work together. And even the slogan for sustainable space economy is saying that it's impact through collaboration. And when you order the newsletter, you will get invitations to our events and webinars, access to our latest reports and the case studies, way to access global networking and collaboration, and especially opportunity to showcase your thought leadership and opportunity to join our collaborative initiatives. And I want to repeat myself, it has been a great pleasure to be with you here today. And I'm really waiting for the next presentations. Thank you for your time.
Thank you, dear Timo. You also can write your website and your contacts in our chat, and we will discuss with you your propositions in our discussion session. And please, our next participant, Dmitro Bondar, Южное CDO. Please, Dmitro. We don't hear you.
Hello.
Oh, now here.
Greetings to all. My name is Dmitro Bondar, and I represent Южное State Design Office. The topic of my report is heat-resistant importance of rocket engines, combustion chambers, and equipment for their vacuum arc deposition. One of the main elements of liquid rocket engines is the combustion chamber, in which fuel and oxidizer are mixed and burned. The combustion chambers of rocket engines operate under extreme conditions of exposure to high temperatures, high speed flows of rocket fuel combustion products. Chemical attack by combustion products can lead to oxidation, vaporization, or nitriding of the chamber surface. As a result, loose and fragile oxides or brittle cracking cemented or nitrided layers are formed. A slide shows impact on the chamber walls of a gas flow with high thermal energy, high temperature, high speed, and chemical activity. The process of coating formation from plasma are promising, which make it possible to control the state of the surface layer of the combustion chamber. Coatings obtained by air and plasma methods are characterized by high adhesion, which is ensured by surface cleaning at the atomic level, by which is ensured. The vacuum arc deposition method is based on evaporation of cathode material by spots of vacuum arc discharge and condensation of a steam of ions and natural vapors on the surface of combustion chamber. The electric field can be used to control the ion condensation energy, that is, coating, structure, and adhesion. The main advantages of vacuum arc deposition method is absence of harmful waste, simplicity and high efficiency of process, low energy consumption, possibilities of regulation of main technological parameters of the process, which allows controlling the surface and properties of coatings. This slide shows uncoated copper alloy space shuttle engine, combustion chamber, and combustion chamber cooling system. The coating must be applied to a complex profile of inner surface of combustion chamber. There is a problem of ensuring a uniform thickness of the coating, which is associated with the orientation of the flow of ions and vapors of the material. Sources of metal plasma have been developed and manufactured, which provide the creation of radial flows of metal ions. These sources provide coatings on the internal surfaces of parts. Sources of metal ions were tested and coatings with a thickness of 30 to 200 microns from molybdenum, chromium, and chromium nickel alloys were obtained. A device for coatings the inner surface of parts with a complex profile has been developed. And the slides show equipment layout inside the vacuum chamber. The vaporizer is the source of the plasma. It's located in the cavity of the part room coating. During the deposition process, the magnetic system of the vaporizer moves according to a given program along the part axis. The device provides a uniform coating thickness on internal surfaces with a diameter of 80 millimeters and above. This slide shows general view of the vacuum unit with the control system. And specimen series of experimental vacuum mark coatings were produced, and their phase composition, microstructure, and properties were researched. The appearance of copper alloy specimens before and after deposition of experimental stainless steel coating is shown on the slide. And this is the end of my presentation. Thank you for your attention.
Thank you so much. For us, it's very important because your organization participates all time in all our exhibition and roundtable. So it's very important for us. Thank you so much that in such difficult times, and you hear that Grigory Mozulevich from Ministry of Education and Science of Ukraine told that Dnipro is heart of space industry. So thank you for your work. And our next participant, Oleksiy Bondarenko, National Aerospace University, Kharkiv Aviation Institute. Please, Oleksiy.
Can you see my
Yes, we see.
presentation?
Yes.
Good day, dear participants of the event. My name is Oleksiy Bondarenko, and I'm a postgraduate student. The designing process, providing and operating system of automatic control and diagnostics of aircraft engines are based on the use of mathematical model. The engine is a complex technical object consisting of many nodes, the joint work of which engenders the work process and determines the parameter of the work process. For example, rotor speed, temperatures, pressures in various sections of flow part, fuel consumption, airflow, thrust, and power. The relevance and complexity of the engine control problem lies in the fact that almost every parameter of an aircraft engine must be within a certain range or not exceed values. The limited parameters in the engine include the rotation frequency of the rotors, the temperature of the gas behind the combustion chamber, and the coefficient of the compressor stability margin. It's these parameters that are limited because they reflect dynamic, thermal, and gas dynamic tension of nodes or parts. For example, in order to extend the lifetime and temperature before the first stage of the turbine is limited. After all, an excess of temperature threatens to reduce the bearing capacity of the turbine blades and even their burnout, the subsequent replacement. On the slide, you can see the consequences of high temperature. For the stable operation, the compressor, the coefficient of stability margin of compressor should be maintained not lower than the specified one. However, controlling is complicated by the impossibility of measuring some parameters for various reasons. For example, long-term management of the temperature behind the combustion chamber is impossible due to the fact that the operating temperature of the thermocouple is lower than the gas temperature. Thrust measurement is based on measuring the force created by the engine, but this method is available only to measure the stability reserve only during bench test when the engine is a state equilibrium. We have a rather complex object in which almost everything needs to be controlled by the number of degrees of freedom is small, often even only 1 degree of freedom, fuel consumption in the main combustion chamber. I'm researching how to use models to identify unmeasured or badly measured parameters in an engine. There are obstacles on this path, and they are caused by the fact that the engine models used not for a series engines, but even for specific one engine with characteristics will begin to give an error in the estimation of unmeasured parameters. The reason for this is the continuous change of engine characteristic during operation, so the dependence between parameters will gradually change. Accordingly, the engine in its current state will not correspond to the build model of a working engine. It has been confirmed at domestic aircraft engine manufacturing enterprises that gas temperature measurement even behind the turbine is not sufficiently accurate. There is models can be used for controlling. Relevance of this topic, one should look at 3 trends in the development of modern engine construction. First, increasing cycle parameters and using variable cycle engines. The obvious way to increase engine thrust or power from engine theory perspective is to increase gas temperature. It can be seen from the development of engine construction that the temperature increases immediately only as materials and technologies allow. This means that there is a tendency to complicate and in the long run the impossibility of temperature measurement. Second, the last half century shows that several different manufacturers offer the same type of engine and the same traction thrust class, but the one with the longest expected lifetime is preferred. And third, aviation equipment has always been subject to requirements for the speed of mode change, which determines the maneuverability of the aircraft. Failure to meet these requirements is critical, especially for maneuverable military aircraft. A peculiarity of control is that a construction between such two indicators of process control as overregulation and regulation time. If there is a temperature reserve, that is possible to increase the temperature and accordingly the fuel consumption acceleration, which will reduce the adjustment time. On the other hand, if the priority to save engine lifetime will allow you to detect the current temperature and keep it at such a level to save the lifetime. This is very similar to setting the car for soft or aggressive driving. In view of the listed development trends, it's important and necessary to use parameter models that are poorly, badly measured or not measured at all. The use of models will allow determine the optimal parameters for controlling, taking into account the adopted control strategies. The parameter estimation model was built, which is based on the calculation of the deviation measured parameters from the parameters of a normal engine determined by the model. On the slide, you can see the diagram of the engine. The model is nonlinear thermal gas dynamic model of the engine with the characteristic of the nodes real engine. I will show the results of the estimation. You can see an array of points on the graph. The red points indicate the results of model, the working engine, and the green points indicate the results of the modified model.
Dear Alexey, I'm sorry, but time, please.
It can be seen that the error has significantly decreased. Therefore, the quality of parameter estimation has increased. Thank you for your attention.
Thank you so much. And our next speaker will be Abhishek Pandey from India. Group insights from above, advancements in Indian space-based remote sensing for agriculture. Please, Abhishek.
Yeah.
Alexey, can you close your presentation, please? Because you see it.
I am not allowed to share the screen.
Yes, you're allowed now, please.
Perfect. Is the screen visible in the full screen mode?
Yes, we see your presentation, please.
Perfect. Perfect. Very good afternoon, everyone. First of all, I would like to thank the organizers of this roundtable for giving me this opportunity to present my insight on the title Group Insight from Above, Advancement in Indian Space-Based Remote Sensing for Agriculture. I am Abhishek Pandey. I am PhD research scholar in the field of agriculture at SCS-VM University, Kanchipuram. Indian space program has made significant stride in leveraging satellite technology for agriculture monitoring. We are in Indian Space Research Organization, ISRO, introduced several satellites spotlighting the missions such as ResourceSat and Kratosat are their pivotal role in the field of agriculture applications. This ResourceSat and Kratosat satellite bolster agriculture monitoring with high resolution imaging. ResourceSat aids the crop health assessment, drought monitoring, and precision agriculture, whereas Kratosat satellite enables detailed mapping, land use planning, and disaster management, supporting sustainable practice and informed decision-making in agriculture. In recent years, India has had witnessed a remarkable convergence in the field of space technology and agriculture innovation, spearheaded by ISRO. India's journey in harnessing space-based remote sensing in the field of agriculture began with the launch of the first remote sensing satellite. It was IRS, Indian Remote Sensing 1A, in 1988. Now, one of the cornerstone in Indian space-based agriculture monitoring efforts in development of satellite, specifically tailored in agriculture applications, satellites such as ResourceSat 2 and Kratosat 1 are equipped with multispectral and hyperspectral sensors capable of capturing high-resolution images with spectral band optimized for agriculture monitoring. These images provide valuable insight into various aspects of crop growth, including vegetable health, water stress, and nutrient deficiencies. Mobile applications such as FarmSAR and M-Krishi provided real-time crop advisories to the farmers and weather forecasting based on the imagery provided by these satellite data. The contribution of ISRO in agriculture monitoring system, including satellite constellation, multispectral and hyperspectral imagining, data fusion, integration, crop monitoring, and yield prediction. ISRO satellite facilitate continuous monitoring of crop growth through agriculture seasons by analyzing the satellite images over time. Customized application and services using the mobile application FarmSAR and M-Krishi. Now, the satellites that being launched especially to dedicate the agriculture crop health monitoring, where one was the very first satellite that was launched in 1988, that was IRS-1A, Indian Research Space 1A. It was launched by ISRO in the orbit of Sun synchronous polar orbit, dedicated to provide low resolution imagery for agriculture application. The next version was IRS-1B. It was launched in 1991 and dedicated for enhanced sensor for agriculture and natural resource monitoring. ISR-1C, dedicated for imaging for agriculture and environmental monitoring. ISR-1D was dedicated in the legacy of ISR series with improvised imaging capabilities for agricultural applications. Now, the development happened in the satellite ResourceSat 2 that was introduced in 2011 in the orbit of Sun synchronous polar orbit, providing high resolution multispectral imaging for the land use and land cover and crop monitoring. Kratosat 1 launched in 2005 that was providing high resolution pan-chromatic imaging for cryptographic application, including land use mapping. Kratosat 2 launched in 2007 provided high resolution imaging for agriculture application. The advancement in the satellite imaging happened by the introduction of ReSat 2, introduced in 2009, providing all-weather day and night image for crop monitoring, soil moisture estimation, and disaster management. ReSat 2B provided the support of all-weather forecasting, day and night imaging for crop monitoring, soil moisture estimation, and disaster management. Now, the study of ours is to learn about resource set series and Kratosat series. Resource set satellite, particularly resource set 2, equipped with sensor as a linear imaging self-spanning sensor and advanced wide field sensor with capture high resolution multispectral images. By analyzing resource set images, agriculture experts can monitor crop growth, detect changes in vegetation cover, assess crop health and stress level of soil, and estimate the crop yield. Whereas a Kratosat satellite, such as Kratosat 1 and Kratosat 2, primarily designed for high resolution panochromatic imaging, although some version also include multispectral sensors. Kratosat images is particularly useful for mapping land use patterns and field boundaries, identification and monitoring changes in crop cover and land use over time. In conjunction with other satellite data, such as resource set and Sentinel satellite, Kratosat images can be used to generate accurate crop maps, assess crop health, and monitoring agriculture practices. These satellites were used especially in agriculture application for crop monitoring, land use, land cover mapping, field boundary delineation, and field estimation, irrigation management, pest and disease detection and identification, crop rotation planning. These satellites also used for border surveillance, provided high-resolution images for monitoring border regions of the country, detecting the illegal crossing and identification of potential security threats. It also supports military infrastructure and monitoring, crisis responses, target identification. And it also supports intelligence gathering for enemies to detect. Now, leveraging these resource set and Kratosat satellite for crop monitoring, the stakeholders in agriculture sector can leverage it to improve crop management practice, leading high yields and increased farm income. Timely detection and response to pest and germicide identification, disease and other crop related risks identification, enhances the resilience of climate variability and weather related hazards through monitoring and adaptive management strategies. Conclusion: resource set and Kratosat satellite plays a vital role in crop monitoring, provide valuable data and insight for informed decision making to the farmers. These satellite images into agriculture practices, farmers, policymakers, and researchers can optimize the productivity, enhance food security, and promote sustainability in the field of agriculture. Thank you so much for this opportunity. Thank you.
Thank you so much. And our next speaker, please, Artur Nikolaenko, National Aviation University, Perspective of IT in Aviation. Please, Artur. Abhishek, can you stop your presentation, please?
Yeah, just I had to stop it.
Thank you. Please, Artur.
You are muted, Artur.
Artur, we don't hear you.
Yeah. Can you hear me now? Okay. So good morning, dear colleagues. My name is Artur Nikolaenko, and I'm a PhD student at the National Aviation University, Kyiv, Ukraine. The topic of my today's presentation is perspectives of IT in aviation. Firstly, let's acknowledge the profound impact of IT on safety and efficiency in aviation. From advanced flight management system to real-time weather monitoring, IT solutions have revolutionized how passenger and crew safety ensured. With predictive analytics and machine learning algorithms, airlines can identify potential maintenance issues in advance, reducing the risk of in-flight emergencies and increasing operational reliability. Moreover, IT innovations have ushered in a new era of passenger experience and convenience. Today's travelers expect seamless connectivity and personalized service throughout their journey, and IT helps to ensure that. From mobile check-in and self-service kiosks to in-flight Wi-Fi and entertainment systems, technology enriches the passenger's experience, offering greater autonomy and comfort. The role of software and technology in aviation industry is continuously evolving. Innovations such as hybrid and electric aircraft technologies, autonomous flight system, artificial intelligence, and the Internet of Things present new opportunities for the sector. Embracing these innovations is crucial for future success of the industry. For example, artificial intelligence and machine learning, which airports will have to use to gain insights into retail spending, security process, travel patterns, restrooms, parking, passenger check-in habits, and so on. This kind of large-scale analysis can only be done simultaneously with AI-based programs and ML algorithms. However, it's not just about airports. Aviation manufacturing also benefits from the insights provided by machine learning. Machine learning and data analytics will be used to detect engine faults, increasing component life, and reducing maintenance costs. For example, Boeing has successfully created ML algorithms for aircraft design and factory operations automation. Next upcoming trend is blockchain. Almost all industries are experimenting with blockchain, and aviation is not different. Currently, blockchain is used in most widespread in aircraft manufacturing. Airbus is implementing blockchain-based solutions into its supply chain tracking to procurement departments and hopes to use this technology to facilitate quicker and more secure transactions, as well as increased efficiencies up and down the chain. In conclusion, the perspectives of IT in aviation are multifaceted and transformative, offering unprecedented opportunities for safety, efficiency, and passenger experience. With ongoing advancements and innovations, the role of software and technology will continue to expand, paving the way for a safer, more efficient, and innovative future in the aviation industry. That's all. Thank you for your attention and for ability to join this roundtable today.
Thank you so much, dear Artur, and for your presentation. So our next speaker will be Teodosija Tsishin, Ivano-Frankivsk National Technical University of Oil and Gas and Center for Information Analytical and Technical Support of Nuclear Power Facilities, Monitoring of the National Academy of Science of Ukraine. Please, Teodosija.
Greetings, roundtable participants. Is it you can see my presentation?
Yes, we see full screen.
Thank you very much. Okay, and in today's presentation, I want to draw the attention of those present to the importance of space science research for addressing the most pressing problem of our time, a global issue, climate change. Okay, in the artificial intelligence generated image, you can see children, us humans, busy solving our problems within our own perspective. However, to grasp the scale of this crisis, one needs to see the bigger picture, if only by looking through the window. Today, we quite several times to the words of Leonid Kadeniuk from the book Mission Space. The biosphere is a general single complex, and when we consider ecology on a local level, we realize that in effect everything is interconnected. It's about the following. Humans have many different missions in space for researching the state of our planet's components, observing its change, and studying greenhouse gases. And this is very good. Since the space research technologies, a number of changes have recorded on planet Earth, which represent a broader vision of the climate change problem. It is important to understand that anthropogenic factors weaken the resilience of our planet in the face of climate change. And recently, we have been recording increased solar activity. It's worth pondering whether we, the inhabitants of Earth, as small as ants, have as greatest impact on climate change, the sun. So, however, to understand the global nature of climate change, it is necessary to compare exciting research on the state of other planets in our galaxy, where there is no anthropogenic impact, but where changes are still accelerating. And for the first time, direct geological evidence of recent volcanic activity has been found on the surface of Venice. And this research also includes data on earthquake on Mercury, the acceleration of Mars rotation, intensification of hurricanal on Saturn, eruption of cryovolcanics on Pluto, and the heating of Jupiter, and and from space, Earth is extremely vulnerable and virtually unprotected. From the height of space flight, our planet is perceived not as collecting of states divided by borders, but as a single wall, and humanity as the unite crew of a spaceship called Earth when travel through space around the sun at speed of almost 30 kilometers per second. It is in some words from the book Space Mission, from our first person who was at the space. And with the scientific community must put together the puzzle unites science to create opportunities to overcome the climate crisis. And thus, we have an important task before us to assemble the puzzle pieces of all scientific research, that is to unite science to create the possibility of solving the climate change facing humanity. And in this aspect, the study of space processing is of utmost importance. And thank you very much for attention. And I see this today roundtable could develop a very good perspective for our collaborating. Thank you very much.
Thank you so much, Theodosia, and you have one message in our chat. So our next speaker will be Mikhailo Shevchenko, National Aerospace University, Kharkiv Aviation Institute. Please, Mikhailo. We don't hear you. But we see your presentation.
Yes. Good afternoon, dear colleagues. My name is Mikhailo Shevchenko. Yes, I'm from National Aerospace University, Department of Aircraft Engine Theory. And today for your attention is a scientific research report for choosing propulsion composition parameter of supersonic cruising of aircraft. It was the topic of my PhD. To also continue working on this research. Development of passenger aircraft that provide supersonic translation flights is one of the promising direction in aviation. There are supersonic business jet perspective design projects you may see in the head top of the slide. Supersonic flight can be provided by various propulsion system composition. Lower on slide, you can see the different propulsion system composition that can change according to cruise Mach number. Therefore, the method which allows to determine the composition and parameters of the propulsion system from the supersonic cruising flight is vital. So, the two-stage method for choosing the most advantageous composition and parameters of propulsion of the aircraft with supersonic cruising speed, a specified flight profiles, geometric, mass and aerodynamics characteristics of the aircraft, which considering flight mode, changes in the mass and aerodynamic parameters during the movement of the aircraft by the criterion of minimum relative mass of fuel and propulsion is performed. And by this method, the optimization problem of the propulsion system composition and parameters of the aircraft was considered by using the development method. Here on this slide shows the required data of the method, geometric view of the aircraft, which had been used for research, the polar of the aircraft for the different flight speeds, and flight profile parameters. Typical for cruising for such aircraft. Also, lower you may see 6 candidates of propulsion system which had been used to research. Is turbojet engine, mixed flow turbofan engine, and 3 of engine on turbo ramjet mode. Is turbo ramjet engine, afterburning turbofan engine, and duct burning turbofan engine. The main assumption of the method are shown on the slide. It was assumed that inlet is adjustable and provides the required airflow for whole flight mode, and the total pressure recovery coefficient of the supersonic was calculated by the normalized dependency. The GT fan is adjustable by tuning the blade and guide vanes. The propulsion system able to provide the cruising flight mode if it elevates obtaining the required thrust and takeoff and cruising modes. For propulsions with aerojet engines on ramjet modes, the flight of the transition to ramjet mode was carried out at Mach number equal to. There's a range of by the way, for each propulsion system composition, the required takeoff thrust can be realized by different working process parameters. The choosing of those values was based on condition providing the cruising flight mode. And the minimum for relative mass of fuel and propulsion system. Working process parameters variation ratio for propulsion you may see on the slide. K is total inlet temperature, afterburning temperature, pi C, bypass ratio, pi C of the fan. Total pressure ratio. The results of the research, which we have on that day, the change of the relative mass of fuel and propulsion system for the selected propulsion system composition, depending on the cruising flight Mach, was obtained. Here with the each point of this dependency correspond to propulsion system with different working process takeoff parameters. It can be seen from the figure that all ranges of the Mach number, the composition between different propulsion system is present. It also can be seen that for different ranges of Mach number, different compositions of the aircraft propulsion system are required to provide the minimum of the relative mass of fuel and propulsion. On the next slide shows the change patterns of the most advantageous takeoff parameters of the propulsion system depending on the cruising during flying turbojet modes. Turbojet modes, sorry. The next slide shows the results. In the results, the values of the most adjustable parameters of the turbojet engine, turbofan engine, mixed turbofan engine, and how these parameters are changed. Lower shown relative parameters of the working process in cruising mode to flight speeds on bottom of the slide. All cruise parameters were related to takeoff one regime or mode. Further, this slide shows the result change patterns of the most advantageous parameters of propulsion system depending on cruising mode during flight speed or ramjet mode. You may see. On slide 12, the values of the most advantageous working process takeoff parameters of the turbofan engine and turbofan engine mixed on ramjet mode, depending on the cruising speed. Slide 30 shows the values of the most adjustable parameters of turbo ramjet engine, afterburning turbofan engine, and afterburning turbofan engine on the ramjet mode. Thus, using the developed methods, patterns of change of relative mass of fuel and propulsion system depending on the cruising flight speed were established for different propulsion system schemes. On the turbojet and ramjet modes, and Mach numbers range from 1.5 and to 4. The established patterns allow choosing propulsion system composition depending on the speed of supersonic cruising flight or choosing the flight speed of the aircraft at a given propulsion system composition. The dependency of the propulsion system takeoff working process optimal parameters on the speed of supersonic cruising flight were obtained. This dependency allows to choose the propulsion system takeoff parameters of the working process that provide takeoff, achieved to cruising mode, and the minimum mass of fuel propulsion. Also, the dependency of the adjustable parameters optimal values and working process optimal parameters of the propulsion system for cruising mode and speed of supersonic cruising flight were obtained. This dependency allows you substantiating the propulsion system control programs that provide minimum mass of fuel and propulsions. There is my constructs. Also, I will send it later in the chat. And thanks for your attention and ability to have the opportunity to perform my research and collaborate with all our colleagues, not only from Ukraine, but also from foreign country. Thanks you a lot.
Thank you so much, Mihailo. And our next speaker will be also from your university, National Aerospace University Kharkiv Aviation Institute, Alexander Shorinov. Please, Alexander.
Thank you. Just a second. I will share. Так, демонстрация. Can you see my screen?
Yes, we see.
Thank you. Dear colleagues, my name is Alexander Shorinov. Thank you for the chance to be here today. And as you can see, the title of my presentation is Cold Spraying for Repair and Restoration of Aircraft Parts. I represent research team from National Aerospace University Kharkiv Aviation Institute, and let me briefly share with you some of our research results. Cold spraying is a coating technology in which spray particles in a solid state are deposited on a substrate via high velocity impact at temperature lower than a melting point of the powder material. The process employs a supersonic nozzle into which solid particles of feedstock material are introduced and accelerated toward the substrate, forming a surface coating. The most important parameter in the cold spray process is the particle velocity prior to impact on the substrate. The actual mechanism by which the solid state particle deform and bond has not yet been fully characterized. It seems possible that plastic deformation may disrupt thin surface films such as oxides and provide intimate conformal contact under high local pressure, thus permitting bonding to occur. To compare with other thermal spraying technologies, cold spraying has some crucial advantages. In deposition, spray materials experience only minor changes in microstructure and little oxidation of decomposition. Most materials such as copper, aluminum, nickel, titanium, and their alloys can be deposited by cold spray. Even some ceramics can be embedded into a substrate to form a thin layer coating in cold spray. Cold spray methods are now recognized and respected as a competitive technology and as an alternative to other thermal spraying and laser cladding or welding techniques. To make advantage of the performance capability of cold spraying process, leading industrial companies such as General Electric, Ford, and Boeing are gradually implementing this coating technique into their engineering process. Cold spraying equipment and technology have considerably expanded and application possibility of the thermal spray techniques. The use of cold spraying technology is reasonable in which in cases where conventional thermal spraying technology cannot be applied. So what we are doing in the field of cold spraying in our university. Actually, we cover all aspects of technology and equipment development for cold spraying, from theoretical description of the process, numerical simulation of gas flow, particle acceleration, particle deformation under impact and coating formation, up to coating characterization of deposited coatings, process optimization, development of equipment for cold spraying, and finally development of technological recommendation for industrial application. Together with our industrial partner, joint stock company Motor Siege, we made a good progress and had successful cases of cold spraying application for repair and restoration of aircraft engine parts. The transition of cold spraying into the aerospace industry and several cases studies are presented below. The case studies show the tremendous impact that cold spray has had for a few selected applications. Two widely used materials for aircraft engines manufacturing, like magnesium and aluminum, are presented while attempting to include as much technical data providing the advantage and benefits gained by the transition of the process. Cold spraying was used for restoration of worn and corroded surface made of magnesium alloy, as you can see in this slide. What else? Also, the technology was applied to repair aluminum and magnesium part with different manufacturing and operation defects, not only for external surface repairing, but also for internal ones. Here in this slide, you can see more examples of cold spray implementation. Here, more examples. To sum up, the cold spray laboratory of our university provides a full range of services in the field of development, equipment, and technology for cold spraying, from process simulation, parameter optimization, coating characterization, equipment development, training, and so on. So thank you for your attention, and do not hesitate to contact me if you have any questions. So thank you.
Thank you so much, dear Alexander, and please also write your contacts in chat. And we have the next speaker, Andrei Havris, Lviv State University of Life Safety. Please, Andrei, floor is yours.
Thank you. You see my presentation?
Yes, full screen.
Okay, thank you for opportunities to take part in your round table. And I want to present my research project. That name for the research ways to integrate the technologies of unmanned aerial vehicles into the sphere of Ukraine civil protection. First of all, I want to say that the use of UAVs will be named like in abbreviation, is becoming more and more widely used every Year to date, unmanned system previously used only for civilian purposes has been further developed in the use of specific conditions such as military operation and search and rescue operation. In order, as you see on the slide, the above mentioned task in the period 2021-2022, the State Emergency Service of Ukraine were a significant supplement with drones, both through public procurements and humanitarian and volunteer assistance. For example, as for the date of December 2022, there are 158 drones in the fire and rescue units in whole Ukraine, and the general distribution of UV by the region you can see in the, as I said in the slide, in the map. As you see, the more drones are in, of course, in Kyiv and Mykolaiv region and Ivano-Frankivsk region. Since the source of supply of aircraft are different, their types and nomenclature differ by the division, and in the next slide, in the diagrams, you can see that the distribution of UAV used by territorial units of the State Emergency Service of Ukraine, according to the manufactured models, are very different. As I mentioned, there are a lot of drones, a lot of types of drones, but as we can see, the most used model today is the Mavic 3 from DJI company. And with such a number and wide range of models that are already used in units of the State Emergency Service of Ukraine, the question arises of the quality of integration of these technologies into the practical activities of civil protection units. Because every kinds of drones, unmanned aerial hacklers have such speciality and opportunities to use. To date, 20 names of various models, as you see, are used, and however, the heterogeneity and unfamiliarity of the personnel of the unit, the specifics of the operation of each model, and their possible use in extreme condition raises the question of the quality integration of this UAV technology into the practical activities of civil protection. And this integration, new technology into a repeat response of the process can present challenges for services, especially when the technology itself is new and its use cases and tactical capabilities to still being explored. That's why the main tasks which we now have and which we want to solve is who will operate the drones and how large will the team for that, where will the drone be stored before use, who and how will transport him to the scene of the accident, for example, emergency situation, how we can use it in a separate emergency situation, for example, forest fire, for example, flood. When they deploy drones, what information should be requested and what information is needed in general, how will information be communicated during this emergency situation, will the drone be used as only aerial inspection devices or it can be used like extinguishing fire, how should it move in adverse weather condition, what should be the training of the drone operator, and the main task is the regulatory requirements exist for the use UAV in emergency situation. And these are not all the questions that arise when accepting a drone for the civil protection service. And for summarize the experience of training UAV operators in the field of civil protection, the author offer certain recommendation regarding their application and everyday use. And we need to integrate this technology, new technology of unmanned aerial vehicles in civil protection with less difficulties and less problems which we can have in the final stages. Thank you very much. Thank you for your invitation one more for this round table. Thank you.
Thank you so much. And now we will have our session of discussion. So we will discuss with you the perspective of collaboration. So you hear all presentation. Maybe you have some ideas with whom you can collaborate or to have the further cooperation. Please, who would like to share ideas, maybe propositions?
If I may comment first.
Please.
So really, it was a privilege to meet all of you today, but it was still the first meeting. And I would be honored if you visit the website, and there's a web calendar. You can see my availability. I would be delighted to have one-to-one calls to continue discussion, and I already have approached a few persons by email or on LinkedIn. So please remember that this was the first time today, and reason why I'm joining here is that I want to build connections with you, and I believe that in longer term we will be doing something great together.
Thank you. So you can visit the website and participate in the events that our team organized. So please, maybe someone would like to share ideas of future cooperation. Maybe you have some proposals to Young Scientists Council at the Ministry of Education and Science of Ukraine. Maybe you would like us to help you to find some partners or something like this for your future cooperation. Or yes, Alexander, please.
Anastasia, I think it would be pretty good if someone can basically create a list and overview of what different, science institutions are doing in regards of space. Like big pillars, like these are doing electronic and control system related parts. These are doing engines. These are doing UAVs and stuff like that. So, and then we can kind of break out to maybe different lines of talks. Because roundtable is good for overview, but also it's nice sometimes to have a bit more closer groups of people who are sharing some ideas and sharing some research areas. That would be my suggestion.
And what about this roundtable? Do you find some future partner for you, especially for you, someone who has similar topics with you?
Well, I think Andrei, who is talking on UAVs, could be interesting partner for me, because we are building the dual purpose platform that can be easily applied to UAVs, for instance. So why not?
Mm-hmm.
Yeah, I share my contact email in chat, and we can write.
Good.
Mm-hmm. Okay, and this roundtable is mostly not about our all Ukrainian cooperation, but cooperation between Ukrainian scientists and foreign scientists. Maybe you can not only collaborate with Timo, but also with Abhishek, who told us today about using of space industry in agriculture. Maybe someone, it's interesting for you this direction. Okay, so we will be in touch. All participants will receive certificates during this week, and also we will have video in YouTube. I will also share with you this video. Timo, you would like to say something, or you just
yeah.
What does
So
it mean?
I was waving because I didn't know how to make it in the system. One thing which I was missing, because I really would like to promote your expertise and make the connections with you and the other European players, for example. I would like to understand what precisely you are looking for. So then it helps the potential cooperation when people know what type of things you are expecting to collaborate, what type of people you want to find?
You mean, so as far as I understand, we will gather information from all our participants. What do you need from foreign partners? Yes?
Yeah.
Okay, it's good idea. So we will, I will write all of you, and you will answer me what you expected of from foreign partners, of kind of cooperation do you want, and I will share it with Timo, and you will help us, yes, to find such
Yes.
European partners.
Yeah, because then it helps
cool.
people know exactly what to expect and how to help. And it might be that your request is not totally matching with their needs, but then they can propose also something.
Yes, it's cool. It's great idea. So thank you so much. We will prepare such list. Also, I think like in 1 week, and it's the same that Alexander told us. So maybe someone else would like to tell something, or we will just finish our today's topic. So you will have video. We will have list of our requests and of our proposals for European partners, and Timo will help us to find these partners according to our request. And we will have video on YouTube in 1 day because we need to work with it. And I will send you, please promote our event, promote our video. And thank you for participation. See you soon.
Thanks a lot. Bye.
Okay. Thank you.